All right, now we're on to Unit 10, which is all about radicals and triangles. And Lesson 10.1 is all about simplifying radical expressions. Now, first off, what is a radical expression? It's just any expression that would contain a radical, like a square root or a cubic root. Anytime that we have that root symbol, it looks something like this. It basically just means like the opposite of an exponent. So this one is a square root. It means the opposite of squaring something. It's how we'd undo a square root. Another term to look for is rationalizing the denominator. This is when we multiply the numerator and denominator of a rational expression by a factor that eliminates the radicals in the denominator. So if we had square roots in the top and bottom, the numerator and denominator, we'd have to multiply by a square root on top and a square root on bottom to get rid of those. So that'll be rationalizing the denominator, and you'll see an example of that later on. Now, if we look over some properties of square roots, an expression under the radical sign is called the radicand. A radicand is in its simplest form if the following conditions are true. No radicands can have perfect square factors other than 1. No radicands can contain fractions, and we want no radicals in the denominator of a fraction. That's when we would have to rationalize the denominator, like we talked about before. So, key concepts. Product property of square roots for any non-negative real numbers, a and b. The square root of a times b is equal to the square root of each of those. So, what it looks like as a symbol here, square root of a times b, you can split it apart into the square root of a times the square root of b. So an example of that would be if we had the square root of 4 times 9. We can think of that as the square root of 36, which we know is 6, or we can split it up and say square root of 4 times 9 is square root of 4 times the square root of 9. Square root of 4 is 2, square root of 9 is 3, and 2 times 3 is 6. Either way, we get to our end answer of 6. Another property to look for, if you square a square root, they basically just cancel each other out. So if we had square root of a squared, this and this cancel out, so we just have a left. And it makes sense because squaring something means times by itself, so square root of a times the square root of a. Those would, because they're the same thing, you're multiplying this by itself, it just leaves a left. Or you could call it square root of a squared, which means those cancel out. And we're just left with a. So for example, square root of 5 squared means square root of 5 times another square root of 5, which means the square root of 25, which we know is 5. Now on the side of your paper somewhere, I want you to write these numbers down. 1, 4, 9, 16, 25, 36. Again, 49, 64, 81, 100, 121, 144, 169, 196, and 125. Now what are those numbers? Why do I want you to write those down? Those are all the square numbers. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so on, all the way down to 15 times 15 is 225. Now these are the numbers we're always going to look to take out of a square root. If we can divide this number out, that'll help us simplify our radicals. And I'll show you what that looks like in some of our examples coming up right now. So for example 1, we need to simplify the square root of 80. Now it's not as easy as just typing that into your calculator and doing the square root of 80 is some number with a very large decimal answer. In fact, that decimal answer is so long it'll never end. So instead of simplifying it that way and giving an answer that's approximate, it's not exact, we're going to simplify it by breaking it down as much as possible. Now again, on the side here, you can see I've written some of the square numbers. It's like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. What we're going to do is think 80 can be divided by which one of these. Now, obviously it can't be divided by 81, that's larger than it. And it's not going to be able to be divided by 64, 49, 36, 25, but it can be divided by 16. So as we simplify it, we break it down and say 16 times 5 would be 80. So the square root of 16 times the square root of 5 would be the square root of 80. This is our first step in trying to break down square root of 80 into our simplest terms. Now that we broke it down into these two pieces, 5 cannot be broken down any smaller. We can break it down into 1 times 5, and that's about it. But 16, we know the square root of 16, it is 4. So we now call this 4 times the square root of 5. Now, instead of writing this multiply sign here, 4 times the square root of 5, we can simply call it 4 square roots of 5, and this would be your simplified answer. So the square root of 80 simplifies to 4 square roots of 5. We're trying to get this square root symbol, whatever's underneath the square root, to be as small as possible. So let's look at example 2 then. We have negative 5 square roots of 15. Now what this means is negative 5 times whatever the square root of 15 or 12 is. So when we break it down, 12, obviously we can't divide 16 by 12, it's too big. 9 doesn't go into 12, but 4 does. So 12 is 4 times 3, which means the square root of 12 is the square root of 4 times the square root of 3. So we've broken it down to negative 5 times the square root of 4 times the square root of 3. Now, the square root of 3 does not simplify. That one's going to need to stay. But the square root of 4, we know, we cross it out and call it 2, because 2 times 2 makes 4. So, as we simplify it, it's now negative 5 times 2 times the square root of 3. And again, we still don't know what square root of 3 is, so we can just leave it in its simplest terms as square root of 3. Negative 5 times 2 is going to be negative 10, so in the end we call this negative 10 square roots of 3. And it means negative 10 times whatever that value, the square root of 3, is. Negative 10 square roots of 3 then is our simplest form. Here we have, for example 3, we need to simplify 6 square roots of 81. As we split it up, that's 6 times the square root of 81, which we know is 9. 9 times 9 is 81. So we broke it down to 6 times 9, which we know is 54. So this one would simplify to just the whole number, 54. Now number 4, there's going to be a couple extra steps with this one. We have 2 square roots of 10 times 3 square roots of 20. So as we do this, we're going to break things down each piece individually. This very first term, this 2 square roots of 10, can be broken into, here's the 2. Square root of 10 is square root of 5 times the square root of 2. So we broke it down into smaller pieces while we're trying to simplify everything. This piece, the 3 square roots of 20, can be broken down into 3 times the square root of 4 times the square root of 5. Because we know the square root of 4, figure that out, that's going to be 2, and the square root of 5 would be left over. Now it's nice that we have that here because now this square root of 5 times this square root of 5 would just come out to 5. And we already know that. Square root of 4 is 2, get rid of that piece. So right now, as we simplify everything, we would say this 2 is still 2. Square root of 5 from right here and the square root of 5 from right here become this 5 right here. This square root of 4 becomes this 2, because the square root of 4 is 2. This 3 whole number stays right here, and the only thing that is left over is this square root of 2 then. Now we've got everything broken down into whole numbers. The only square root left was this square root of 2. So we just say 2 times 5 is 10, times 2 is 20, times 3 is 60. So it would be 60 square roots of 2. We just try to break down the square root part as small as we possibly can. Now if we wanted, we could have also done 10 times 20 is 200. So we'd have 2 times 3 is 6, so 6 square roots of 200, and then break it down from there. Or you can break them all down into individual pieces. Here we have just one big square root, and this one also includes some variables. We have square root of 112x squared y. That whole thing is underneath our square root. So as we break it apart, 112 is 16 times 7. And we just do that by guessing and checking through that list of all of our square terms. And we find that 16 was the biggest square number that goes into 112. So this 112 became square root of 16 and square root of 7. We still have square root of x squared, and we have the square root of y. Now, if we look at that, we know that the square root of 16 is 4. We can get rid of that piece. Square root of 7, there isn't one, so that needs to stay. Square root of x squared, those cancel out, and we just have x, and the square root of y does not change. So this is now, let's get rid of that, 4 times x times the square root of 7 times the square root of y. And when we put everything together, it becomes 4x square root of 7y. This would be your final answer. And for example 6, we have the square root of 2x cubed times the square root of 6x squared. Now, like example 4, we're just going to break it down into a lot of little pieces. We have the square root of 2, came from right here. Now this x cubed, I'm going to break into two different pieces, an x squared and an x. Or if you want, we can think of this as x to the first power, because x to the 2 and x to the 1 would multiply to this x to the 3. Now, why did I break x to the 3 into a 2 and a 1? Well, because I know the square root of x squared. I can cancel that radical symbol and the 2, I can cancel them out. So this would just be x. This one still stays, but at least I was able to simplify this part. Now as we keep going, this, the square root of 6x squared became square root of 3 times the square root of 2 times the square root of x squared. And again, I can cancel that out, and now I know I have another x. Also, as I look at these, I see square root of 2 and another square root of 2. So those will simplify to just 2, which means I've got 2 right here and here. So that went right here. I've got an x right here. I've got another x right here. And then a square root of x and a square root of 3. So 2 times x times the square root of 3 times the square root of x. Now at the end of all things, you can put everything that was underneath the square roots together. So this would become square root of 3x. And we can multiply all of our whole number pieces together. So 2 times x becomes 2x squared. So our final answer is 2x squared on the outside of our radical symbol and 3x on the inside of our radical symbol. That would be our final solution, our most simplified form of that expression.